I am not going to be talking about the basics of how to find like areas of triangles or circumferences of circles. Those are things that you should already know how to do. And if you've forgotten the formulas, go look them up. They're in your book. They're also in this little place I found called the internet. Okay, so you can just find them and use them. We will discuss perimeter, area, and volume. Actually, we won't do volume in this video, but it's in your homework. We'll apply formulas to solve, and we'll probably have some bad sketches here and there. But I'm going to start by finding the area of this shape right here. I can't actually do the perimeter of this shape because I have no way of knowing what these two lengths are. But everything else I can work with. I'm going to find the area of this shape. The best way to do that is to think of it as separate shapes. It has a triangle here, a small rectangle here, and a big rectangle here. I'm going to think of this in three separate categories. Triangle, small rectangle, big rectangle. And I'm going to structure my work in that fashion. I'm going to find the area of the triangle. I'm going to find the area of the small rectangle. I'm going to find the area of the big rectangle. That's how I'm going to be thinking about how I do this. But that means I also want to find some other lengths. Okay, so let's play for a second here. If this length right here is 15 and this is 10, then this must be 5. Okay, this length right here is 5. Another one. If this length here is 40 and this is 20, then this guy right here and this guy right here must be 20. And here's the one that's going to be toughest for you to see. Okay? I also need to find this height, the height of this triangle. Well, if this length is 15, that means what's left is 13. So there's 15 here and 13 here, so this height is 13 meters. So I've now found all the lengths that I need to find these areas. Okay, to find the area of a triangle, it's 1/2 times base times height. And the base right now is 20, and the height is 13. So 1/2 times 20 times 13 is 130 square meters. Area is always in a unit squared, so it's square meters. Area of a small triangle is just base times height or length times width, which is 20 times 5, right? Here's the base, here's the height, 20 times 5. That's 100 meters squared. For the big rectangle, it's going to be this 10 by this 40. I'm getting too scribbly now, but this 10 by this 40. That's 400 square meters. I add all of those up, and it's 130 plus 100 plus 400, so it's 630 square meters. Boom, we found the area. Now we can't do the perimeter because we don't know this length and we don't know this length. However, if we knew one bit of details, if we knew, say, that these were both the same, they're both length A, if those two lengths were the same, then we could find it. But we don't know that, so we can't. Okay, another way you could do this problem that isn't how most of you are going to think about it, but you should start thinking this way. Okay, this method I'm going to show right now isn't the best method for this problem, but it's helpful in the future. Instead of thinking about it as three little shapes to put together, you could think of this as being one big rectangle with a missing piece. A piece cut out of it, okay? A big rectangle with a piece cut out of it. So you could ask, what's the area of the whole big rectangle I just made? And that's obviously 15 times 40, right? Here's 15, here's 40. And then I could take out the area of the little shape, which is 20 times 5. If I did 15 times 40 minus 20 times 5, that would give me the area of this piece, this leftover piece. Sometimes doing subtraction from a big piece is better than doing addition of smaller pieces. That's an important thing to remember. Okay, sometimes subtracting from a big chunk is faster, easier, better, simpler than adding together smaller chunks. Something to remember. Okay, I'm going to find the area and perimeter of both of these shapes. The first thing I should do is think, well, what are these shapes? How would I describe these shapes? If I can describe these shapes, then maybe I have a shot at finding their values. Well, I think of this shape here as being a rectangle with a semicircle on top. Semi means half, with a half circle on top. Now that I've described it that way, I realize if I can just find the area of this rectangle and the area of this half a circle and add them together, I've found the area of the total shape. So I'll do that. A couple things I need to be aware of. We're not told these are right angles down here, but we're just going to assume that they are. If these are right angles, then this is also 100 inches over here. Okay. The area of the big square, rectangle actually, is 42 times 100, which is 4,200 square inches. To find the area of the half circle, I have to do 1/2 times the area of a circle, which is pi r squared, right? Area of circle is pi r squared, but I'm cutting that in half because I only have half a circle. So I'm going to do 1/2 pi r squared, which is 1/2 times pi times whatever the radius is. Do you know what the radius is? Well, if this is 42, then this is 42, which means that the radius is 21. So it's 1/2 times pi times 21 squared. Pi r squared cut in half. Well, 1/2 times pi times 21 squared, I'll just do it in my calculator. Look, here's my calculator. It's pretty great, except when it doesn't work. Let's get rid of you. Let's try it again. .5 times pi times 21 squared. 692.7 inches squared. If I took this and added it to this, I know that the area here is going to be 4,892.7 square inches. Sick. Next, let's do the perimeter. Perimeter starts out easier. It's got 100 plus 42 plus 100. But I also have to add in the perimeter of the half circle. Okay, that P with that little thing there saying perimeter of half circle. Okay, well, how do I find the perimeter of a half circle? I know the perimeter of a whole circle is 2 times pi times r. So the perimeter of a half a circle, I'll draw that half circle better. The perimeter of half of a circle is 1/2 times 2 times pi times r. And 1/2 times 2 times pi times r is actually just pi times r. So if I do the 100 plus the 42 plus the 100 plus pi times my radius of 21, I'm going to get the perimeter. 100 plus 100. I can't believe I just typed that in instead of typing 200. Yeah, this is just 242. I'm going to stop being an idiot. 100 plus 42 plus 100 is just 242 plus 21 pi. 307.97. So the perimeter of this shape is 307.97 inches. Perimeter is just inches, whereas area is inches squared. Okay? If you're doing an area, it's the unit squared. If you're doing a length, it's a regular unit. If you're doing volume, it's the unit cubed. So 3 dimensions, 3 powers, unit cubed. Okay, here's just kind of fun. And, you know, whenever I say fun, you probably panic a little bit because it's like things that are fun for math teachers aren't fun for math students that often. But stay with me here. The perimeter of this is going to be the exact same as the perimeter of this, because this is just 3 sides plus half a circle. And this was 3 sides plus half a circle. So the perimeters of these two shapes are the same. The areas, however, are completely different. You'll notice this is the same rectangle, 42 by 100. However, instead of adding half a circle, we're subtracting half a circle. So I can think of this as the area of the rectangle minus the area of the half circle. Well, I already found the area of the rectangle. It's 4,200. And I've already found the area of the half circle. It was whatever 1/2 times pi times 21 squared was. I didn't write that down, so I'm just going to have to calculate it again. But I just have to subtract instead of add to find the area of this shape. You have to think of it as this is a rectangle with a circle taken out of it. So since I took out the circle, I'm going to subtract that from the total area. 4,200 minus 0.5 times pi times 21 squared. Pi r squared. I typed something wrong. This is supposed to be a pi. There we go. 3507.27. Nice. One more. I'm not actually going to do this one all the way. I just want to show you how to think of it, because you'll start to see problems like this a lot. There's a purple circle, and then there's this bluish region around that purple circle. And we're told the diameter of the purple circle is 15 meters. So I'm just going to just show that. I wonder what color's best. Probably like purple, like a dark purple. This whole diameter here is 15 meters. No, not that whole diameter. The diameter of the purple circle, the inside circle, this here is 15 meters. The distance from the edge of the purple circle to the edge of the blue circle is 4 meters. So this right here is 4 meters. But that means this right here is also 4 meters. Find the area of the blue shaded region. So we are trying to find this area here. Okay, here's the big old trick, the absolute key to this. Think of this as being the area of a blue circle. Okay, the area of this whole circle as if it were filled in, the area of the blue circle, minus, I'm going to pick a different purple. I'll just go here. Minus the area of the purple circle. Think of it like you used to have a really big old blue circle that was filled in like this. But then we took out a whole bunch of it by coloring it purple. And everything that I just colored in is no longer blue, it's now purple. So if I do the area of the blue circle minus the area of the purple circle, I can get that done. Well, that involves finding radii, a radius, right? The radius of the blue circle, to find this area, is going to be pi times r squared. And the r is from here to here is 23 meters, which means that the radius is half of that, 11.5. So that's pi times 11.5 squared. The area of the purple circle is pi times 7.5 squared. I do this minus this, I find the area of the blue region. Let's not waste time with the actual calculations here. Recap. Think of odd shapes as a collection of known shapes. Draw and label diagrams. Putting on units and measures and lengths is so helpful. If you don't know a formula, look it up. Again, big secret, the internet. Sometimes subtracting from a larger shape is better than adding up smaller shapes. Boom. We're done. We did it. We got through another math video. Thanks for watching. Here I'm going to play with the perspective on these shapes while I talk to you. Please subscribe to the videos, like the videos. Okay, start this thing over. You did it. You got through the video. Thanks for watching. I'm going to play with the perspective of these shapes, which is always pointing towards that center while I talk to you about things. Please subscribe to the video, the channel really. Please like it if you found it helpful. If you want to share it with friends and say, hey, this guy's not the worst, that's an option too. You can always take your video quiz if you're in my class. And comment down below. See you next time.